Welcome to series of database management system video lectures. Today we'll be discussing about Unit 3, Topic 2.2, that is implementation of indexing concept using MySQL database. So from Unit 3.1 and 2 topics, we have discussed about what is indexing technique and what are the various classification of indexing techniques and how this can be used in this is MySQL database. So I have access to two proper credentials. Now let us access to our database. I have already created a database using AR. So let us display what are the databases which are available as part of this. So here is a list of databases which I have created and worked with. So let me pick AR database. So use AR database. Finally have changed it into the database. Now let us display various tables which are available in this database. Here is a list of database tables which I have created. Now let us create a new table for best understanding of indexing concepts. So now before we create a table with the name employees, let us confirm, do we have any table with employees? Yes, we have. Let me drop table employee. That profiling is done successfully. Now let us see what are the various profiles which have been created. So now it shows that there are no profiles which are created so far, which means that so far we didn't created any indexes on any table. Now let us create a table. Now this is the table employee which we wanted to create with the four attributes, that is employee ID, name, position, and then salary. Okay. So let us create a table with this. The first attribute is employee ID, which can be of type integer. Now, this ID attribute should be created using primary key. So I want to create this using a primary key as the attributes should not take duplicate elements. And the name, which is of type varchar. You can mention the size to be of 30. Choice is up to us. And the third attribute is position. Position is also a combination of characters. So varchar of then I have taken to specify the designation, and the last one is salary. Salary which can be taken into float, but then I have taken is int, right? So this is how a table has been created with the employee information. Now let us insert some data. Employee values. So now we need to insert the same set of data items. One Alice manager 80,000. Manager 80,000, the salaries of. Now one record is successfully inserted. Now let us change the values according to our table. Bob analyst 60,000. Now here, the first attribute value should not be duplicated. So that's the reason we gave the value to be 1. Let us see whether it accepts the same 1 value or not. So now let us giving information that you cannot enter the value to be repeated, right? As we have applied a primary constraint upon that attribute. So let us change the value here. Fine. Now the second record has been inserted. Now let us insert the third record. The third record information is Carol manager 85,000. Who is of manager position. He has 85,000 of salary. Okay. Right. The third record is successfully inserted. Now fourth record, which Dave developer 75. with a 75,000 of salary. Now, final record is Eve analyst 62. So 62,000, right? So with this, we have successfully created the records in employee table. Let us print. Let us display the content of this table. Here is the table which is created. Let me describe the structure or the schema of this table. This gives a detailed information about the table. So now we have four attributes: employee ID, which is of type integer, and it cannot be null as we have applied a primary key constraint to it. So that's the reason it is showing this. And by default, null value can be accepted here. Now the second one is name, which is of varchar type with a length of 30, and that where null values can be accepted as we did not apply any other constraints. And position, which is also of varchar type, and null value can also be accepted. And salary, which is of type integer, null value can be accepted, and by default, it can be taken as null as. So this is the schema of the employee table. Now, the minute when we have inserted the record onto the table, we can set the profilings to be this. So earlier we did not apply any index concept. So that's the reason show profiles even now will display as empty only. Show profiles will show that what were the various operations that have been taken so far upon this table. So here I have inserted 5 records and then I have written a query for displaying the content of it, and then I have displayed. So what can be the operations that have been performed upon this table is very clearly displayed. Now, when I wanted to look into each and every operation in detail with respect to this ID number, the first, let us see here in this manner so that, yeah. The query ID, show profiles will be given in a tabular format with the 3 attributes. One is query ID, second is duration, how much amount of time which has been taken to perform the operation, and what was the command which is given by the user, right? So let me get a detailed information about query ID number, right? So you can write the command like this: show profiles for query 1. So what has happened for executing the first query? So what was the first command? This is the first command. You are trying to create a table with a few set of attributes. Now to perform that, what are the various operations that gets involved? So here is the detailed status that is given by the profile. So it has started at this point of time at the 717 seconds, and it has taken execution amount of time to perform that operation, and it has started at this point, and it is going to validate whether the permissions have been given to create the table or not. To verify that it took this much amount of time, and then to access to a specific table, it has taken this 1670 milliseconds of time. And then for creation of a table, it has taken this milliseconds of time. And after creation, after successful creation of it, this has responded with this status. And then we are waiting for the handler to commit. So once the table is being created in the database, it should be equally reflected in the hard disk itself. And then where the query has been ended, at what time the query has been ended, at how much amount of time it has been taken. And then for closing of tables, it has taken this much amount of time, and waiting for a handler to commit, and freeing items. So once after successful creation of the data item, what were the other associated handlers that have been used for performing the operation, and we need to release all that. And this amount of time has been taken to perform that. And for cleaning up of all the operations, 54 milliseconds of time has been taken. So to perform one particular query or a command in SQL, it takes or it does these set of detailed operations, and this is the duration of time which has been taken for performing it or to carry out each and every operation. Right. So now similarly, you will be able to retrieve even for query 2, that this is for creation and this is for insertion of a data. You can see it here. What is query ID2? Query ID2 is for inserting the data into the table, right? So this is for the second one. When it has started, each and every detailed information can be retrieved with respect to the timestamp. Okay. Now we will create an index. Before we create any index on the table, let us see, do we have any indexes which are created? Let us get the list of indexes which are created upon this table. Okay. Yeah. This would be better for looking at the whole thing. Yeah. So show index from student one. So far, we did not create any index here. We did not create any index manually. But then how come we got this information? So now, as for the table name, this is for student one. Let me get for employee. For employees. Yeah. So the table name is employees. The table name is employees. And then it is non-unique index. We have not implemented that. So that's the reason 0. And what is the key attribute where we have applied primary constraint? So what was that? That is the column name upon which we have applied primary key constraint. And it is following sequential indexing concept and collation when we are merging more than one table. And then this can be taken as collation value and cardinality. So which represents that how many such instances of the table can be taken for accessing to the other table, whether it is a one-to-one cardinality or a one-to-many cardinality or many-to-one cardinality or many-to-n cardinality that can be represented here. As we have 4 attributes, so cardinality can be taken as a 4. Now, subpart, we did not do anything. We did not pack anything. Null. Now, the index type. How do you arrange the data for indexing to access to the specific data? Any type of indexing which is going to be represented in the internal memory, the form of a B-tree architecture. So this was the thing that data structure is being used for the representation of data. Then comments were not given anything by us and index comment. And visible, yes, the index is visible to us and it cannot be evaluated based upon the expression. So this is the detailed information that you can retrieve from the primary key attribute which we have applied for the at the time of creation of the table. Manually, we did not create any indexes so far, but then with a primary key constraint, which can be treated as a primary index. Okay? This is a primary index which is being implemented here. Let us look at the next one. Now to have more detailed information about that. To have more detailed information about the employee table. Now, for executing this particular query, let us select a start from employees. What was the selection type? Whether it is a simple or complex selection statement that has been used, wherein the querying has been used with respect to joins or any other aggregate functions that have been used. No, it was simple. And then upon which table it has been used. And partitions. We did not partition our table yet, so that's the reason null. And type, wherein all the data members can be accessible. And the possible keys. We did not mention any keys here, only primary key that has been used, and by default it can take null values. Yes. And the key length, we did not mention anything. The reference, we did not create any link to the other tables. That's the reason the reference is being taken as null. And how many number of records that we have inserted is 5. And then this has been filtered based upon the primary key attribute by taking this amount of time. And there were no other additional things that have been defined upon this employee table. That's why null is being displayed. Let us create We have already done primary index, right? The second one is secondary index. Let us create a secondary index. Now, what do we mean by a secondary index? Already we have implemented a primary key index there in the above example. Now, secondary index means that not only just with respect to the single indexing structure, we wanted to retrieve the information based upon the position of the employees. So when I wanted to write my query in this manner, that is, select a star from employees where position is manager. Now I wanted to write a query to display all the records based upon the condition that only the position which matches to manager. I wanted to retrieve only those set of records. So in that case, the main feature that I need to look at, a quick lookup can be done with the help of the manager position only. So if I have defined the index table by considering this particular attribute, then it will ease us to retrieve the data in a fastest manner. So that's why we have changed that. So this is the secondary index how we have implemented here. Now if we write the query here, we will be able to retrieve all the records of the employees where the position matches with only manager, right? So this has taken very less amount of time for retrieval of the data. This is secondary index. Now the third one is clustered index. Here we are taking the same employee table. Now upon which we wanted to create a clustered index. Let me write the syntax to create a clustered index on this employee table. Now we will find out that what is the key attribute. Employee ID is the key attribute. Now, in this manner, the data is stored in the table with the name, position, and then salary attributes. Do we have any related data items which are similar to each other? When you look at employee ID, we will not find any values which are same. So, as employee ID is a unique attribute. Name, there is a possibility of having same names. Position, for the same position, there can be different set of employees who are working for. And sometimes the salary figure may also be same. Now, depending upon our requirement, I wanted to filter only the records of the position matches with the manager. If I wanted to retrieve that kind of data records, then I need to create a clustered index using this create clustered index and the index name upon the table employees by using position. By using position. If we write like this in the background, if we create like this, the physical table is going to be ordered in this manner. Employee ID, name, position, salary. All these are going to be restructured based upon the position. Now, all the positions which are similar, now let us create a clustered index upon this employee table. Now we have employee ID key attributes, name, position, and then salary attributes. Now if we wanted to group the related data items together, so when we write the creation of a clustered index in this manner, create clustered index, index name upon the employees for the attribute position, it creates an index table. It creates an index table in this manner, wherein the search key and the data reference key is going to be taken by search key for position. And then data reference key can be the address. Now here the actual main table which is going to be created, which is already available, the employee ID, name, position, and then salary. Okay. So the employee ID is one. First thing is it retrieves the first record, that is manager. So position manager information is maintained here. And then the data reference will be, assume that this is in block 1. So this starts at 2000. So this 2000 will be maintained here, which points to this. Now, in this table, all the employee records related to manager position only is maintained. Okay. How many manager records that we have? Two we have. One is one ID and then three. Their names are Alice and then Carol. And Alice's salary is 80,000 and then Carol's salary is 85,000. Now this can be treated as one cluster. And the second block, the second cluster, which will have analysis, the same one, which will be taken in block 2, which starts at 3,000. So next is analysis, which starts at 3,000. So in this manner, the index table, clustered index table is going to be prepared. So here, analyst of ID2, whose name is Bob, with 60,000 is going to be stored here. And then next, the second analyst is obtained for 5E with the same analyst. And the salary is 62,000. So this again forms as another cluster. And the third cluster will be for the other one, that is developer. Okay. So this can be maintained in block 3 at 4,000. So we'll be using developer here, which can be obtained from the memory location 4,000. And the developer have 4E, then the value is 75,000. So in this manner, the records are fetched for the clustered indexes. Right? Now, hope you understood this. Moving on to the next one, non-clustered index. When this non-clustered index can be applied. Now, I wanted to retrieve the information about the employees based upon their names. So now, when there is a possibility of having repeated names, then you can group it by using clustered index. And when there are no repetition of the names, or I wanted to retrieve the record by name, I wanted to write my query in this manner. I wanted to select star from table name where the employee name is Alice. Table name where name equals. Now I wanted to write this sort of command. So this can be taken as an index. Now index table is going to be created. A non-clustered index table is going to be created based upon the name attribute, so that you can have a very quick lookup by comparing with the starting character of the value which we have provided with all the records in the table. To do that, we will use the syntax, that is non-clustered syntax. This is creates non-clustered index upon employees table with the index name and then passing the name upon which it gets created. So this will have a very fast access to the required records. Next is unique index. Now unique index can be created this is for unique index. Now I wanted to retrieve all the distinct values. Whenever we write the command using distinct keyword, select a star from table name. Select star from table name, distinct upon the name values, name attributes. Then in the background, it creates a unique index table, index structure, and accordingly, it maintains all the names and that can be taken into the index table. And that's how you will have a very quick access to the data items. Yeah. So now this is how we do. And the next one is composite index. Now, when you wanted to retrieve, let us write this. Now, I wanted to retrieve all the records of the employees where the condition which I'm mentioning here is name should be Alice and he should be with the position of manager. So here two different attributes information have to be maintained. In combination with these two only, the matched record should be obtained. So this can be done with the help of writing the composite index, creating a composite index by passing both the key attribute values into one. This we have already done. Create a simple index name on employee table. Earlier we have passed only one attribute, but now we are passing two attributes, more than one attribute. This is called as composite key. Whenever you create a primary key, which is a combination of more than one attribute, can be termed as a composite key, right? So to retrieve this sort of thing, we create a composite index for a fast retrieval of data, right? So we have created that. And when we write the query like this, it will be helpful for us to fetch the data rapidly. The next type of index here is bitmap index. This bitmap index can be used whenever we deal with large data warehouses, wherein huge group of data items are stored in tables, and we need to have fast accessing to the data. Then we create this bitmap index, which reduces a lot of research time. And the next type is function-based index. Now here the records are going to be filtered based upon the built-in function which is being implemented upon the data attributes. Now look at here. Now here is the command create index name upon table name. Now I wanted to convert the data of name attributes into uppercase letter. Based upon that, I wanted to apply an index table upon create an index so that you'll be able to retrieve the information. The next full text index. So this is again for retrieving the complete names of the employees. Earlier um, we have taken to retrieve all the records where the name matches with based upon the name I wanted to retrieve the records, right? Now there the character by character is going to be compared so that it will be a tedious job which takes a lot of search time and access time. So to reduce that, full text means the whole query will consider the name first and accordingly the match is being done, the search is being done, which again have a drastic reduction in the search time. And then finally, we have dynamic multi-level indexing, which makes dynamic multi-level indexing, which allows us to have a data structure, which is termed as a B plus tree for fast accessing of data. The records are going to be maintained in such a way that in a tree structured manner, wherein we have a root element, and then we have two child elements or the leaf nodes, child nodes, and then every child node can be further broken down into two child nodes. And then the subsequent child nodes can have leaf nodes. So the leaf nodes will have the pointers to the address for fetching the records, and the child nodes can be taken as the other attribute values, which can be further subclassified. So this is the example that we can look at, and then we can relate to the example. So this almost works in the same manner as that of general B plus tree data structure, which has been used in fast search navigation of the tree for identifying the records as well as for the data items. So this will be the end for indexing types of indexing techniques which are practically implemented.